In Module 2, Lesson 4, we're going to extend our practice of adding integers and other rational numbers to finding a more efficient way than having to draw a number line all of the time. So in example 1, we will start again with the number line, but we'll work our way into a good rule from there. We're going to represent the sum of 3 plus 5 using arrows on the number line. So starting at 0, we would first of all go to 3. And then we would continue going from 3, we would go another 5. The arrow that represents the 3 is 3 units long. It points to the right. The arrow that represents the 5 is 5 units long, and it also points to the right. We're then asked what the sum of the two numbers is, and we can see that we landed at 8. And if we were to represent the sum with one arrow, that arrow would be 8 units long. Continuing with the discussion, the relationship between the arrow that represents the number on the number line, meaning the answer on the number line, and the absolute value of the number is that they are at exactly the same distance from 0. And then finally we're asked, do you think that adding two positive numbers will always give you a greater positive number? And judging from our number line example, we started at 0 and went a certain distance to the right, and then because our second number was also positive, we started at that ending point and continued going that many more to the right. So it would stand to reason that as we continue going right, we will continue to get a greater positive number if we are adding two positive numbers. In part B, then, we're asked to represent the sum of -3 plus -5 using arrows that represent the -3 and the -5 on the number line. We'll use the same questions for our feedback. And if we were going to play the integer game, we would combine -3 and -5 to get -8. Quickly represent this and find that when we go -3, 3 units to the left, we would then continue another 5 units to the left because it is also a negative number, and that would give us -8. The arrow that represents -3 is 3 units long, and it points to the left. The arrow that represents the -5 is 5 units long, and it also points to the left. So our sum is -8. If we were going to represent the sum using an arrow, our arrow would be 8 units long, and it would point in the left direction. We can see that because both of our arrows are pointing left, so we would add those absolute values onto each other. And because everything is going left, our answer would always be negative. Our final question for that example is, what do both examples have in common? And hopefully at this point, you should have noted that both examples had two numbers that were pointing in the same direction. The arrows both pointed in the same direction. So we were simply adding on for the numbers, and the answers were increasing in magnitude. So our first rule, put in short form, is you add integers with the same sign by adding the absolute values and using the common sign. At exercise 2 then, we're going to look at these numbers and decide whether the sum, first of all, will be positive or negative without calculating the sum. So if we add a -4 and a -2, we would assume that that answer will be negative because we are going to the left for both numbers. If we add +5 and +9, our answer will be positive. -6 and -3 would be negative. -1 and -11 would be negative. 3 plus 5 plus 7 will be positive, and -20 plus -15 will be negative. Then in part B, they ask us to actually find the sums of these individual problems. And 15 plus 7 would be 22. -4 plus -16 would be -20. -18 plus -64 would be -82. -205 plus -123 would be -328. And now in example 2, we will look for the rule for adding opposite signs. So in this example, we're going to represent 5 plus -3 using arrows on the number line. 5, being a positive number, would be 5 units, pointing to the right. And then, from that 5, we need to go 3 units, pointing to the left, because we are adding a -3. And that will land us at 2. Answering the same questions, the arrow that represents -3 is 3 units long. And it is pointing left. And the arrow that's longer, the longer arrow, is the arrow that represents 5. So our sum is 2. And if we were to represent that sum using an arrow, our arrow would be 2 units long, and it would point in the direction to the right. We'll go ahead and put that arrow in just to represent it. Our answer, which is where we landed from our second arrow, would be at +2, which is 2 units away from 0. And it is pointing in the right direction because from 0, we need to travel to the right. Let's look at example 2, part B. Which are some different numbers. And we'll draw our arrows. Again, there's a +4 for arrow 1. And then we're adding -7 from our landing point at 4. So if we count down 1, 2, 3, 4, 5, 6, 7, we know that we're going to land at -3. In the 2 examples above, what is the relationship between the length of the arrow representing the sum and the lengths of the arrows representing the p-value and q-value, or representing the 2 numbers that we are adding? The relationship between the length of the arrow representing the sum and the lengths of those 2 arrows is that they are actually, the length of the arrow of the sum is actually the difference between the lengths of the 2 arrows representing the problem. If we take our last arrow, which is 7 units long, and our first arrow, which is 4 units long, we get 7 minus 4, which equals 3. And the length of the arrow in our sum, let's just draw that in, is 3 units long. The relationship between the direction of the arrow representing the sum and the direction of the arrows representing the p-value and q-value, and again, we haven't focused on those terms, but we can see that the p-value and q-value they're referring to are the two numbers that we're adding. The relationship between the direction of the arrows representing the sum and those two other arrows is that the arrow representing the sum is pointing in the same direction as the longer of the two arrows. In other words, the larger magnitude number is determining whether the answer is positive or negative. Then you're asked to write a rule that will give the length and direction of the arrow representing the sum of those two values that have opposite signs. We spent some time in class doing this, and I want you to develop your own at the moment, and then we'll take a look at it a little further. So the rule that's printed for us: add integers with opposite signs by subtracting the absolute values and using the sign of the integer with the greater absolute value. This is a great rule, but you need to write it in your own words first, and then you need to come to a full understanding, because this rule is the first time that we start to really determine whether you understand the concept or not. If you're still not real strong on the concept, you might want to draw some number lines for these and make sure that you can truly picture the answers. Nevertheless, in exercise 3, we are going to circle the integer with the greater absolute value and decide whether the sum will be positive or negative without actually calculating the sum. So when we look at A, we can see that 2 is the larger number, and that means that our sum is going to be positive. 9 in part B is the number with the greater absolute value, so our answer in B will be negative. In C, the larger absolute value would be negative 6, so our answer will be negative. And finally in D, negative 11 is the larger absolute value, so our answer for D will be negative. Then, just like we did in the last exercise, we're going to actually find the real sums for number 2. So if we take a look at the problem, negative 10 plus 7, they have opposite signs, which means that they're going to go in different directions on the number line. So what we'll need to do is subtract their absolute values. And 10 minus 7 is 3. And the answer will be negative because the larger absolute value is a number that is negative. In question B, we are again adding numbers that are going in opposite directions on the number line. So we'll subtract their absolute values. And 16 minus 8 is 8. Our answer will be negative because the number with the greater absolute value is a negative number. Likewise, in question C, they have opposite signs. meaning that they are going in opposite directions on the number line. And we subtract 65 minus 12, which will give us 53. But in this case, the larger absolute value is a positive number, so our answer will be positive. And then finally, in example D, again, the numbers have opposite signs. So we will subtract their absolute values, and the number that it has the larger absolute value is negative 126. So our answer will be negative 21. Now when we look at example 3, we're going to apply these integer addition rules to rational number problems as well. And rational numbers simply mean that we are also working not only with integers or numbers that have no fractional parts, but we're also working with numbers that have fractional parts, including decimals. So the rules don't really change, but the way you subtract or add will have to follow the rules for addition and subtraction of fractions and or decimals. So if we look at finding the sum of 6 plus negative 2 1/4, we first want to find the absolute values of the numbers, and the absolute value of 6 is 6, the absolute value of negative 2 1/4 is 2 1/4. We will have to subtract their absolute values because they have opposite signs. They're going in opposite directions on the number line. So we are actually going to subtract 6 minus 2 1/4. And simple regrouping, if we take 2 away from 6, that would leave us with 4, and then we need to take 1/4 away from 4, which would mean we would have 3 3/4 left over. The larger absolute value was a positive number, so our answer will also be positive. Then in exercise 4, they have a variety of problems for us to take a look at, mixing all different types. Finding the sum of negative 18 plus 7. They have opposite signs, so we'll need to subtract their absolute values. 18 minus 7, which is 11. And the larger absolute value is a negative number, so our answer will be negative 11. In question B, a little word problem, it says if the temperature outside was 73 degrees at 5 p.m., but it fell 19 degrees by 10 p.m., what is the temperature at 10 p.m.? Write an equation and solve. Remember, ladies and gentlemen, this is an addition problem, or we want to represent it as an addition problem. So we'd be starting at 73 degrees, and we would be adding negative 19 degrees to represent the temperature falling by 10 p.m. So our equation is 73 plus negative 19. They have opposite signs, so we'll need to actually subtract their absolute values. And our answer will be positive because the larger absolute value is a positive number. And that will give us a positive 54. In question 3, you're going to write the addition sentence and find the sum using the diagram. Based on the diagram, we can see that we are adding numbers with opposite signs. And our first number, which is closer to the number line, is negative 10. Then we'll be adding 3 1/2. And 3 1/2, since our arrow is pointing to the right, would be a positive number. So we're adding 3 1/2. To solve that, again, probably the easiest way for these simple fractions would be to take 3 away from 10, leaving us with 7, and then take 1/2 off of 7, which would leave us with 6 and 1/2. But our answer has to be negative because the greater absolute value is a negative number. The lesson summary for this lesson is very important because the rules for adding integers are extremely important to get straight before you start trying to subtract them, which we will do in lesson 5. Then continue on with the problem set to make sure that you have adequate practice.